Our job is to make sure that the whole satellite assembly is intact throughout its life. A satellite experiences 11 times acceleration due to gravity during its launch phase. This aluminum structure has been designed to withstand them.
Our job is to generate power from the solar cells and to distribute it to the other subsystems. The batteries are also charged, and these batteries supply power when the satellite is in the eclipse region. Most of the PCBs that we use are designed, manufactured, soldered and tested in our lab.
Satellites are launched into space to conduct specific scientific experiments, which are their payloads. We are flying two payloads on board. The first being thermal imaging. Here we intend to monitor the Indian subcontinent by measuring the temperature differences over the sea, the clouds, and between urban areas and their rural surroundings. Our second payload is the electrodynamic tether experiment. Conventionally, satellites are left in orbit even after their mission life, contributing to space junk. Our electrodynamic tether experiment intends to demonstrate a cost-effective method for deorbiting these satellites. It is basically a conducting wire which, when lowered into the magnetic field in presence of plasma, exerts a retarding force on the satellite which will deorbit it.
We are the voice of the satellite. Our main objective is to transmit the payload data from the satellite. The ground station that we have designed is already operational and tracking other satellites.
The satellite needs to know where it is in the orbit at a given time so that it can point its payload, which is the camera, towards the Earth, and can also ensure that there is a communication link between the satellite and the ground station. This is achieved using a system of sensors and actuators and various other complex control system algorithms.
We provide the computer architecture to ensure proper functioning and coordination between all the subsystems.
This is Team Manipal Racing. We are Manipal University's official off-road racing organization. This year we went for two events. The first one was Baha Student India at the Buddh International Circuit, New Delhi. The second one was Baha SA India at the NATRIP testing facility, Indore. The current version of our ATV, the V6, was designed to endure two events, Baha SA India and Baha Student India. To make the car, we divide our year into three phases. The first phase is the design phase, where we make sure that each component that goes onto the car is designed by us. It is followed by the manufacturing phase. Herein, we try to keep the tolerances low and the quality high. The last phase is the testing phase. Our car was tested for 50 hours in various challenging conditions. Being strong and robust, it pulled through successfully. We are currently working on the next iteration of our ATV, which is the V7. V7 will be compact and extremely lightweight. We are trying to achieve this by controlling even the number of layers of paint and the number of spacers. All these minor details will help in improving the future model.
There's always room for improvement regarding designing and manufacturing of our vehicle, and which can be brought about by better utilization and provision of funds. For example, Magod Laser, we've had a good long-standing relationship with them, and they've helped us out with precision laser cut components.
Another very helpful sponsor has been Dell Hydromatics. They have helped us with a lot of CNC work with resources or assistance from sponsors. There's a lot of work, there's a lot of improvement that we can do to the car, and we could then build what we would call a no-compromise car. The reluctance of companies regarding provisions of funds or services is justified because companies would raise an eyebrow regarding their resources being used effectively.
At TMR, we are extremely transparent about the work and how we go about it. Our current and prospective sponsors are more than welcome to come down and pay us a visit at our workshop at any instance.
Robo Manipal is the official robotics team of Manipal Institute of Technology. It consists of 30-odd multidisciplinary students who share a common passion for robotics. Robo Manipal is a blend of disciplines including mechanical, electronics, coding and management. We represent the college in robotics and automation competitions. We primarily compete in the International Annual Robotics Competition, ABU Robocon. This year, the problem statement is about energy conservation. We are to make 2 robots, one driven and one driving. The driven bot has to clear an obstacle course autonomously, being wirelessly powered by the driving bot. As such, we are utilizing wind energy for this purpose. This year, we have improved in all aspects, implementing finite element method analysis as well as fluid simulations, incorporating high current power electronics, and having designed and fabricated printed circuit boards, integrating high precision control systems as well as complex algorithms. Needless to say, testing and practicing is an important part of this process. Most importantly, none of this would have been possible without the immense support we have received from our faculty advisor, college, and our director.
Solarmobile is Manipal University's official solar car team, and our car is Solar Electric Road Vehicle, that is India's first solar passenger vehicle. My name is Arvind Naik. I'm in my 4th year of engineering. I've been part of the Solarmobile team since my first year. Right now I'm in the senior technical team. India receives a lot of solar power, 2 into 10 power 8 kilowatt hour. According to research, we can use at least 1% of that energy to drive our mobility needs in passenger vehicle platform. We wanted to bring a solar passenger vehicle into the market that does not depend on the fuel prices and is clean for the environment.
After designing, the main step towards the completion of the car was the manufacturing stage. I'm Anubrat Gangopadhyay. I joined Solomobile in the powertrain segment and went on to lead the manufacturing team. We started with the chassis. Complete chassis was welded in our workshop by our teammates. After that, we had to move towards the manufacturing of the powertrain, which was the main heart of the car. The final and the most important stage of any car is the bodywork. Our bodywork is made up of fiber reinforced plastic. That material has to be molded, which was a very difficult task, which was done in Udupi as well as in Bangalore. That was the intricate shape of our car.
When it comes to electrical cars, you require a lot of safety, and the first thing that people think of electrical vehicle is the electrocution and shocks and other things. So actually there are a lot of safety standards that you have to obey and you have to take care of. I'm Rishikesh Rao. I joined in my first year under the Autotronics and DAQ subsystem and eventually went to lead the subsystem. There were a lot of parts in this car where we had to actually redesign and come up with new ways because there were no such conventional ideas or protocols that could actually fit our requirements. After a lot of brainstorming, we finally managed to redesign certain aspects of conventional vehicle which would fit a solar vehicle and actually make it perform much better.
In January, we faced a big problem, which was that we were supposed to take this car for international competition, but we couldn't because of delays. All the 3 years of effort which had been put in could have gone in vain. I am Amol Grover and I joined Solomobile in Structures division, but later went on to lead the mechanical part of the team. To justify all the help and support which we had got from university and the industry, and to fulfill that dream, we finished it in the next 4 months and finally were able to launch the car on 22nd April 2015.
Campus Diaries reached out to us and discovered us to showcase our project at Young Innovators Space at InnoFest 2015. It was a huge success because Mr. Jayant Sinha drove the car and Mr. Mohandas Pai actually sat in the car. So we got a lot of praise from the industry. So it was a great success. Solomobile has completed 2 cars till now. First car was a single-seater car. The second car was a 2-seater passenger car, which was first in India. We wanted to show that as students, we got it to this level. Now, as industries, you should take the next step and bring out this kind of project into the market. So the next team has to improve on this car. We are in a phase of constant improvement. That's what I think defines Solomobile. We want to showcase to the world that we are going to bring this to the market. That is the legacy that we are going to leave behind.
The margin for error is so small. I mean, 1/2 a step too late or too early, and you don't quite make it. 1/2 second too slow, too fast, you don't quite catch it. The inches we need are everywhere around us. They're in every break of the game, every minute, every second. On this team, we fight for that inch. On this team, we tear ourselves and everyone else around us to pieces for that inch. We claw with our fingernails for that inch. Because we know when we add up all those inches, that's going to make the difference between winning and losing. Between living and dying.